In this video, we're going to be taking a look at HSRP. Now, HSRP is the Hot Standby Router Protocol. It is Cisco's proprietary first hop redundancy protocol. And we need to kind of understand what the difference between HSRP is and how it operates, what its goal is, so that we understand what's operationally going on and stuff like that. So there are two versions of HSRP. Version 1, which is the default, and it is configured and started by a group number of 0 through 255. And what it does is it sends out multicast addresses to 224.0.0.2, which is the all routers multicast group. There's an all hosts, which is 224.0.0.1, and the idea here is if you're sending to 224.0.0.2, you're trying to talk to other routers. And what this is going to do, this is link local, which means that in order for HSRP to work, the HSRP devices have to be on the same LAN segment so that they can basically act as the same default gateway. Now there is an HSRP version 2 and has basically went and it uses a new multicast address, and it has a slightly different packet format. It uses a different multicast, or I'm sorry, it uses a different MAC address as well for its HSRP operations. So let's talk about what HSRP does before we dig into any of the other details, because if we don't understand what it operationally is used for, what's the point, right? So HSRP is designed as what they call a first hop redundancy protocol. So you might say, what does first hop redundancy mean? Well, first hop redundancy is something like this, where I have a device here and I have a device here. Now let's assume for just a moment that there's a LAN segment connected between these two devices. Now let's say that off of here I've got, you know, PC1, I've got PC2, and I've got PC3. Do this. That's going to bug me. And we've got PC3. These guys are all connected to this. Now, this LAN segment is just simulating a shared segment. There could be multiple switches in between. It really doesn't make much of a difference. Now, what's happening here is these are two physically different devices. It's not a stack or anything like that, or a VSS pair. What's happening between these two is each one, in a normal deployment without a first hop redundancy protocol deployed, what you're going to have is this IP address. This guy's going to get IP address .1, for instance, and this guy will get .2. Well, that's all well and great, but each one of these interfaces is going to have a different MAC address. Let's say it's got A, and this guy's got B. And let's say, for instance, that you specify that the default gateway for each one of these is .1, and its MAC it learns is A. Same thing here, .1 and MAC address A. .1 and MAC address A. Great, everything should work as planned, which means that everybody should follow the yellow line to get to this guy, right? So PC3, PC2, and PC1 should all go this direction to get to the default gateway. They're going to follow this line, but I didn't want to gum up this one. So that works all well. But what happens if this link right here, this MAC address A, this switch, whatever, fails? Well, what's going to end up happening is the devices down here, the PCs, would have to get some sort of update. Now, assuming that all the PCs have manually configured IP addresses, what will end up happening is someone's going to have to walk around to manually configure each one of the PCs with a new default gateway. Let's say it's .2. Then the PCs have to go out there and learn what .2's MAC address is. So now we've gone to .2/B, .2/B, .2/B. Okay, you get the point here. They all have now, and then this guy here is no longer being used, .1/A. Now everybody's using .2/B. Okay, that works, right? So now everybody's sending their traffic this way now, right? Everybody's going this way. Well, here's the thing. If, let's say that this guy comes back to life, the switch A. Switch A comes back to life, and it is the exit point of the network. But the both of them, for the sake of argument, have access to the same upstream network. So there's no traffic comes into B, has to get hairpinned back out and sent back to A. Both of them can send the traffic without issue. Okay, then that works, but every time there's a failure, whether it is whether that failure, whatever the reason behind the failure, what has to happen is either a manual or a dynamic update has to happen. The PCs, the endpoints in the network, need to learn a new default gateway. Okay, well, maybe 20 years ago in a network of 10 users, that wasn't such a big deal. But this is middle of 2017, and most of my customers have more than 20 users. They have hundreds of users. And I'm sorry, I am not going to walk around and manually configure the same IP address settings 100 times every time there's an issue. I'm just not going to do that. Why? Because I'm smarter than that. What I'm going to do is I'm going to enable some sort of first hop redundancy protocol, which means I'm going to basically configure this guy here and this guy here to talk to each other. What I'm going to say is for whatever VLAN, let's say VLAN 10, I'm going to come in here and say, you know what, I want both switch A and switch B to be able to communicate with each other and share the responsibilities. So I come in here and I use the standby command, standby group 1. I'll say standby group 1, and I set the IP address IP to .3. Okay, an IP that we haven't used. Same thing over here, standby group 1 IP .3. So what this actually does is two things. This actually creates a third IP address. This is the IP address that all of your end stations would get, the .3. So then .3 now becomes the default gateway. .3, .3, and .3. Okay. What ends up happening is when you create the standby group 1 and you configure it, and then these guys start to talk to each other via this LAN segment, what ends up happening is a HSRP MAC address is formed. Now, I don't remember that 0 something or other off the top of my head. I don't remember. I'd have to go look it up. If I was to see it on a, if it was like, if this was a test and it popped up, I would know by looking at it what it is. But to tell you off the top of my head, honestly don't remember. I'd have to actually go look at the command line and see what the show the ARP command is. But what's going to end up happening is when you configure HSRP, you're basically creating what they call as a virtual node. This virtual node is going to have an IP and a MAC. The group number here, this group 1, is going to be inverted into hex at the very last 2 digits of the MAC address. So if you see the XX, the last 2 digits in the HSRP MAC address is the group number. In this case here it would be a 01. What's going to end up happening is you're going to have this called the V virtual MAC address, and you're going to have a virtual IP address. The virtual IP address is the .3. So that's .3. So what ends up happening is you get .3 and you get 01 as the MAC. What ends up happening is these guys both agree on this information because they're both in standby group 1 with the IP of .3 on both sides. They're communicating through link local multicast to the all routers multicast. Because of all these identical configurations, what they're able to do is they're able to agree with that, and then one of these two is going to become the primary. Now, what ends up happening is usually the MAC address is the tiebreaker. What I can do is I can set what they call, there's a few options. There's the priority. We're going to talk about preemption. We're going to talk about authentication. And we're going to talk about tracking. So the first thing I want to touch on is going to be priority. Now by default the priority is 100, and if I want a particular device to take over, I'm going to tell, say, the priority of, say, 110. So I'll say I want this guy to be 110, this guy will be 100. Now you don't type in priority 100, he automatically has that. What ends up happening is this guy becomes the active device. This guy goes into standby. It's active in standby. What ends up happening now is, because they're both switch 1 or switch A and switch B have agreed upon this configuration, both of them advertise the same MAC address and the same IP, but one of the two goes into active mode. If this guy here is the active, that means that PC 1, 2, and 3 are going to send their traffic towards host A, or sorry, switch A. By sending everything to switch A, then we know where we're going. What ends up happening if switch A goes down, you might ask? Well, what ends up happening is, after a short period of time, which is actually about 9.1-ish seconds, traffic will be redirected over to the switch B device because of the timers. Now the timers, they are sent out every 3 seconds as the hello, and then you have 3 plus a little guy left over, so you get full 3 dropped hellos plus, like, I think it's like 300 milliseconds is what would be the very beginning of the 4th hello range. And what this basically does is it gives you the full 3 seconds, or the full 9 seconds, and then part of the second, or part of the fourth one, which is, I don't know, 150, 200 milliseconds. It's something very short. And then if it fails over, then everything swings over to switch B. But because of the fact that they're advertising the same MAC address and the same IP, the end stations don't need to change anything. There's no MAC address flush, because you don't need to relearn a MAC address. The MAC address stays the same. They share amongst the information. Now you get this preemption option here. Preemption basically says, if I have both of these devices to participate in HSRP, what's going to end up happening is switch A checks out, goes to lunch, doesn't come back. You RMA the switch comes back, and then you say, well, I want this guy to be the primary, or the active for. Normally what people are going to do is the odd VLAN, say switch 1 is going to be the default gateway and the root bridge for all odd VLANs. Switch 2 will be the default gateway and the root bridge for even VLANs. Something along that logic line, which is fine. I've done that plenty of times myself. So we get the failover capability. So what preemption does is, what it's going to do is it's going to say, you know what, I'm going to preempt after, say, 60 seconds. So after 60 seconds, I'm going to go ahead and I'm going to cause a reconvergence in the network. I'm going to take over as the primary. So I personally don't really care, but you might have some reason behind that. And if you do, sure, I'm not going to argue that. If you tell me you need everything to be back on switch A if switch B fails, maybe switch B is a lower model switch and doesn't have the horsepower to handle it. For a period of time, it's okay, but every day over and over and over again, not so much. That's fine. I personally don't care. As long as you're getting the results you need, I'm good with that. You fail back over to this guy. You can authenticate this through a hashed password to make sure that you're not getting a switch that is jumping into the configuration that shouldn't be there. And you can track. So let's say, for instance, I track this upstream link to the internet. Let's say this guy goes down. Well, I want to make sure that if this guy goes down, but this guy is up and good, that I can fail over based off of that. I can track, well heck, gig 0/1 is down. I can't forward traffic, so basically I'm black holing everything right now. Let's fail over to switch B, who is up and running and still good to go. There's communication between the switches. They know what's going on. And because they know what's going on, they can hear it, they can see it, they can smell it, they can taste it. They know what's happening. So they know what's going on. They can go ahead and fail over at whatever point in time. So what we're going to do in the next video is we're actually going to go through the configuration of HSRP and make sure you guys understand all the details behind it. So we're going to create an active and a standby for each one of the VLANs we have created so that we know we have reachability where we got to go. We're going to take a look at configuring the priority and stuff like that, making sure that switch 1 is the primary, switch 2 is the backup. We'll take a look at preemption and authentication and tracking. as well and go from there. Until next time, guys, thank you so much for checking us out, and we'll catch you guys in the next video.